Hi everyone. In this video, I want to go over some of the questions of chapter 4 as an example and give you an idea for those who may have any questions and they're struggling to answering some kind of these types of questions. Um, I chose some questions randomly and I want to go over them and then try to have the questions that covers most of the topics in chapter 4. The first question, it says a local bakery has determined the probability distribution for the number of cheesecakes that they sell in a given day. So as you see, we have a table, we have a probability distribution table. X is the number of, it's a random variable, which is the number of cheesecake that they sold. And the second row is the probability for selling each of that number of cheesecakes. So for example, the probability of selling 0 cheesecakes is 0.21. The probability of selling 5 cheesecakes, it's 0.31. 10 cheesecakes is 0.13. 15 cheesecakes, oh, we don't have the answer here. So first of all, we need to complete the table. And as we know, this is a probability distribution table. And the probability distribution tables always have two properties. First of all, each probability must be a number between 0 and 1. And as you see, all these numbers are numbers from 0 to 1. And we know that in every probability distribution, the sum of all probabilities must be equal to 1. Let me change the color. Okay, so based on that, I can find this missing value. So if I add 0.21, 0.31 by 0.13 and 0.15 and subtract it from 1, I can find a missing number. So now I'm just adding 0.21 plus 0.31 plus 0.13 plus 0.15. And if I subtract this number from 1, I will find that this number must be 0.20. So the probability of selling 15 cheesecakes is 0.20. Now the question is asking, what is the probability of selling 15 cheesecakes in a given day? Okay, that's the first thing. What's the probability of selling 15 cheesecakes? Is 0.20. The second part is this, and you will see that it's 0.20 or 0.2. The second part says, what is the probability of selling at least 10 cheesecakes? At least 10, at least means the minimum, the lowest number that we can have. That means we can have 10 or more. So when they ask you in any question, at least 10 means 10 or more. Okay, when I look at the table, 10 or more means just these three values. And you know that is 0.20. So what is the probability of at least 10? And you know whenever we have or, we need to add. 10 or more means 10 plus 15 plus 20. Because these are the x value in my table. And I need to add the probability of these. Probability of them is 0.13. These are all probability, guys. Don't get confused. Plus 0.20 plus 0.50. And if you add these numbers, you will get 0.48. The next part is asking, what's the probability of selling 5 or 15? Okay, 5, the probability of selling 5 is 0.31. The probability of selling 15 is 0.20. And you know, whenever you have or, you need to add these answers. You need to add the 0.31 by 0.20. The answer is 0.51. Next part is what's the probability of selling 25 cheesecake? Okay, when will you look at the table, there is no 25. So what is the probability of selling 25 cheesecakes? 0, because we don't have the 25 on the table. Next part is asking that give the expected number of cheesecakes sold in a day. The expected number means find the expected value. Find the average of the number of cheesecake that they sold in a day. Okay, and to find the expected value, which is the exact mean of any probability distribution, we need to multiply each x by p of x and then add them together. So in this table, we need to multiply 0 by 0.21, which is 0, multiply 5 by 0.31, multiply 10 by 0.13, multiply 15 by 0.2, multiply 20 by 0.15, and then add all these results. And you should have 8.85 as an answer, which is the expected number of cheesecake which is sold in a day. That's the average number of cheesecakes that they sold. And then last part it says what is the probability of selling at most 10. Okay, at most means the maximum 10. Means you cannot have more than 10. So 10 or less. 10 or less means 10 or 5 or 0. Because in the table, I only have 10, 5, and 0, which is at most 10, or at most 10. Now I need to add the probability. You just need to add these probabilities. 0.21 plus 0.31 plus 0.13. Okay? Let's look at next example. Next example, it's a game. Yep. It says, suppose that you are offered the following deal. You roll a 6-sided die, and if you roll a 6, you win $12. If you roll a 4 or 5, you win $2. Otherwise, you pay $5. It says, complete the PDF table, the probability distribution function table. And it tells you that X is the profit. So that means the numbers that you should put for the X values should be the profit. And if you roll a 6, you will win $12. So 12 is one of your X's. If you roll 4 or 5, you will win $2. That's a profit. And if in other cases, you pay $5. Pay $5, that means the profit is -5 because you don't get, you just lose money. Okay, so these three values are the X values, are the profit. And it tells you that from smallest to greatest. So make sure to put them from smallest to greatest, -5 first, and then 2, and then 12. Now we need to find the probability for each of these X values, each of these random variables. So when do we get -5? When the profit is -5? So if we don't get 6 or 4 or 5. Okay, let's find the other one, then we get back to this one. When do we get $12? When we roll a 6. So when you roll a 6-sided die, the sample space is all the numbers from 1 to 6. So you have a chance of getting 1, 2, 3, or 4, or 5, or 6. Now when they ask you, you roll a 6, to find the probability, you have to see how many 6 do we have in this sample space. It's just 1 over, and the sample space is 6, so it's 1 over 6. So the probability of winning $12 is 1 over 6. Now, what is the probability of winning $2? $2 is when you roll 4 or 5. Or means add. Remember that. So what is the probability of getting 4? Again, is 1 out of 6. What's the probability of getting 5? Is 1 out of 6, but because of that or, I need to add them together. And 1 over 6 plus 1 over 6 is 2 over 6. And if I simplify this one, it gives me 1/3. So the probability of getting 4 or 5 is 1/3. So the probability of winning $2 is 1/3. And otherwise means not rolling 4, 5, and 6. That means rolling one of these three, 1 or 2 or 3. So for each of them, the probability is 1/6, 1/6, and 1/6. When it says otherwise, that means rolling it 1 or 2 or 3. That means I need to add them together. And if I add these three, it gives me 3 over 6. And if I simplify, it gives me 1/2. So the probability of losing $5 is 1/2 or 50%. After completing the probability distribution, now you need to find the expected profit. Okay, let's see if we can use an online calculator. If you go to Canvas and open the online calculator, you will see the link number 6 is expected value and the standard deviation. And if we open this one, it asks us to type all the numbers for x and p of x in the table. So then let me just erase these parts. Okay. So the table is over here. So you can just type the numbers. For x, we have -5, 2, and 12. And the probability for -5 is 1/2. I know you can just type, you may not be able to type fraction. You need to change it to decimal. But in this question, you can work manually. You don't necessarily need the online calculator because there are only 3 numbers and it's easy to just use the handy calculator. And 1 over 6, which in decimal is 1 divided by 6 is 0.17. And then if we calculate, it gives us the expected value and the standard deviation. Okay, but we can also calculate it manually. So just multiply -5 by 1/2, and then multiply 2 by 1/3, multiply 12 by 1/6, and then all add them all together. And if you have problems of multiplying fractions, whenever you have fraction, and if you want to multiply numbers to fraction, let's keep everything in fraction form. And we know whenever we want to multiply two fractions, we need to multiply the top by top and the bottom by bottom. So we get -5 over 2 plus 2 over 3 plus 12 over 6. With add or subtract fractions, we always need the common denominator. And the common denominator is a denominator that's divisible by all of the denominators. And since I have a 2 and a 3 and a 6, the common denominator can be a 6. When you find the common denominator, you need to compare each of the denominators by the common denominator. The first denominator is 2. Now the common denominator is 6. That means you need to multiply by 3, so you do the same on top. The next one is 3. Now we have 6, so you need to multiply it by 2 to get 6. Multiply the top by 2. And then last one is 6. The common denominator is also 6. If there is no change at the bottom, we don't change the top as well. And now you can add the tops. 12 plus 4 is 16. 16 minus 15 is 1 over 6. Okay? So I recommend to do it manually when you have fractions, and especially when the fractions are repeating fractions. For example, if you divide 1 by 6, you will see that you have a decimal number that it's repeating. It doesn't stop. So if you want to round it to a number, you probably get a different number. Okay? And it may be different and it marked you wrong. Okay? So you see it's 0.166666, which is exactly the answer for 1/6. But when I used the online calculator, it gave me 0.2 because I round those numbers, and the rounding, it will change the expected value here. Okay, so I recommend every time you have fractions as your probability, work with the handy calculator and work manually. Okay, now after finding this expected profit, you will see that the expected value is positive. Whenever we have a positive expected value, it means that the game, so it's good if we play the game, because the chance of winning is more than the chance of losing. The game is fair. If the expected value is 0. If it's negative, the chance of losing is more, and if it's positive, the chance of winning is more. Now it says interpret the expected value, and you say, okay, this expected value, this positive value tells me that if you play many games, you will likely win an average very close to 0.17 per game. Yeah. And it says based on the expected value, should you play this game? If the expected value is positive, yes, why not? So you say yes. Okay, yes, since the expected value is 0, nope. Yes, because you can win $12. I don't think so. Yes, since the expected value is positive, you would be very likely to come home with more money if you played many games. Okay? But if you look at next example, you see that you have a complete probability distribution. In this case, since we have decimal number for the probability distribution, and we have and decimals are not repeating actually, it's okay if we use online calculator. So we can go back to this one and erase these values and type the new values. Okay. So 0, 1, 2, 3 are the x values. 0, 1, 2, and 3. And 0.48, 0.34. I know on the exam you may not be able to copy the information, but you just write it down on a piece of paper, on your scratch paper, and then copy it into the online calculator. 0.13 and 0.05. Okay, now let's see what do we get. So the expected value is 0.75. So it says, first of all, it says, is this valid discrete probability distribution? So a valid discrete probability distribution means every probability must be a number between 0 and 1, which when you look at this one, you see that they are. And the sum of these probabilities must be equal to 1. And if you add this number, you see that yes, if you add them, they add up to 1. So you can claim that yes, this is a valid discrete probability distribution. Yes, since the sum is equal to 1 and each probability is between 0 and 1. Now it says find the mean. Mean is exactly the expected value. We found it here is 0.75. And it says find the standard deviation. Again, we have the standard deviation here on the online calculator. We can type it there, 0.86.46. Sometimes you can look at these purple to make sure that in how many decimal digit you need. It doesn't mention right now, but sometimes it does. 0.8646. It says, oh, the question says give your answer to at least 3 decimal places. At least means you can have more than 3 decimal places as well. Okay. Now it's asking to find the sigma square. Sigma square means the variance. And we know that the variance is always the square of the standard deviation. Okay, so this is my standard deviation, the sigma. Now I want to find the sigma square. Just square that one, use the calculator and see what do we get. 0.8646. If I square it, it gives me 0.7475, and it has more decimal digit, but I can stop here because it's just asking me to at least 3. Now, if I submit this question, you will see that all answers are correct. Let's look at another example. It says, in this example, it says, according to a recent survey, 82% of students say that they do not get enough sleep. Assume the survey meets the conditions of a binomial experiment. Okay, I have a binomial distribution here. I know all the properties of the binomial distribution. All of the binomial distribution, in all of the binomial distribution, you must have fixed number of trials. And if you read the rest of the question, you will see that it says there are 28 students. That's a fixed number of trial. Then the probability of success must stay the same in all trials, and that's a probability of success. And so you need to check all the conditions, but these two are the most important one. Okay, now it says find the probability that exactly 26 of them out of the 28 students, exactly 26 of them say they do not get enough sleep. So we have a binomial distribution, and we want to find the probability when x is exactly equal to 26. So I hope that you remember the formula for the binomial distribution, which is n factorial, x factorial, n minus x factorial, p n minus x, q x. Okay? Or maybe p to the x, q. I need to check the formula. But I'm now going to use this formula by hand. I want to use the online calculator for it. Okay, if you just want to work manually, you need to write the whole formula, make sure you have the correct format of formulas, and then replace numbers. So in this trial, we have n, which is 28, x is 26, because we want to find the probability when x is 26. P is the probability of success, which is 0.82. And Q is the probability of failure, and which is always 1 minus P. And when P is 0.82, 1 minus 0.82 is 0.18. Okay? If you want to use the formula, these are the information that you need to plug into the formula. But if you want, you can use the online calculator. Let's see how we can do that. If I go to the online calculator, to the homepage, you see that we have number 7 is the binomial probability. Okay, if I click on the binomial probability, it is asking me to put the lower bound and the high number. Okay, lower and upper bound. If you go back to the question, when you want to find the probability when x is equal to 26, when x is equal to 26, that means the lower and higher is both 26. You want to find the probability from 26 to 26. Number of trials, we have 28 students, and the probability of success, which is 0.82. Okay. Now let's calculate. And that's the answer. 0.0703. And let's see. Yeah, see, the correct answer is also 0.0703. In the second part, it says, in a random survey of 28 students, find the probability that more than 26. More than 26 means you want to find the probability when x is more than 26, x is greater than 26. Okay, that means numbers that are more than 26, but they are still less than 28 because we only have 28 students. So 26, 27, 28. We have to stop at 28 because we only have 28 students. When it says more than 26, we don't include 26 as well. But if it says, instead of more than, if it says at least 26, you need to include 26 as well. But right now it says more than 26. More than 26 is just 27 and 28. That means you want to find the probability of 27 and probability of 28 and then add them together if you want to work with the formula. But if you want to use the online calculator, okay, I wish I had this one. Let me just put it here. The probability of 27 plus the probability of 28. Now, what's the lower? It's 27. Now the higher number is 28. We have 28 trials. And in this case, I don't think we need to put both of the trials on the higher number. Maybe it asks us to just fix it. Okay, and the answer is 0.0276. 0.0276. You see, we get the same answer. The last question is also, it's about the binomial distribution. Because when I read the question, I see that it says, suppose the college is considering a new computerized placement test, which has 48% of all the students taking remedial arithmetic. It says, if 12 randomly chosen students take the placement test, what is the probability that exactly 8 of them will have to take remedial arithmetic? Okay, when I read the question, I see that in this question, I have fixed number of trials. So the n is 12. And each trial has only two outcomes, success or failure. They take the remedial test or do not take. Okay, so each trial has only two outcomes. And the probability of success is the same for all trials. When it says 48 take the remedial test, that means the probability of success, the probability of taking the test is 0.48 for all the students. And I know the Q is always 1 minus 0.48, which is 0.52. So when I check all the requirement for the binomial distribution, I see that it works in this problem. So that's a binomial distribution. Okay. If you want to work with formula, you just need to write the formula, and based on each part, you find the probability of that specific x values. But I'm going to use the online calculator to make it faster because the formula is a little complicated and is just time consuming, especially on the test. So I try to use online calculator. I want you all practice to make sure that you can open the online calculator on the exam. Otherwise, you need, if you can't open online calculator for any reason, based on the device that you have, I don't know what, but if you can't open the online calculator, you may need a TI-83 or 84 calculators. Because when we move on to the next chapter, we really need these online calculators. Some problems is really, it's not possible to find answers manually. Okay. The first part, it says if 12 randomly chosen students take the placement test, what's the probability that exactly 8? Exactly 8 means the probability of 8. Okay. If I go back to the online calculator, put this one again here. Okay. I want to find the probability of 8. Probability of 8 means the lower and the higher number in this interval is both 8. From 8 to 8, the number of trials are 12 randomly students, and the probability of success is 0.48. And the answer is 0.0183. 0.0, oops. Did I put something wrong? Oh, I put 28. I'm so sorry. We have 12 students. The number of trials is 12. Yep, is 0.102. Yep, the same. Part B says if 12 randomly chosen students take the placement test, what's the probability that at least 7? So at least 7 means the probability when x is 7 or more. At least means include 7 as well. If you want to use the formula, you need to find the probability of 7, 8, 9, 10, 11, and 12. You need to find each of them separately and then add them together. And you see how hard is that one if you want to use the formula. Now we go back to the online calculator. This time, the lower number is 7 and the higher number is 12. Because we have 12 trials, the probability is 0.48 and the answer should be 0.3343. Yep, that's right. Part C, it says, if 12 randomly chosen student taking the test, what's the probability that at most 3? At most 3 means 3 or less. That means you need to find the probability of 3. You need to include them. For at least and at most, we have equal sign as well. So we need the probability of 3, we need the probability of 2, and we need the probability of 1, and we need the probability of 0. All the numbers less than 3, from 3 all the way to 0. You need to find all of these probability and then add them together manually. But if you use online calculator, if we use the online calculator, okay, now the lower number is 0. The higher number is 3. Let's see. It's 0.0943. 0.0943, yes. Okay. Now in the other two parts, it says if 772 new students take placement test. So this time the n is 772. Okay. So remember that's your n value. And there's a binomial distribution that describes how many will need to take remedial arithmetic. And what is the mean of this distribution? Okay, this time is asking about the mean of the distribution. And if you look at the slides, you will see that the mean of any binomial distribution is n times p. N is the number of students who are taking the test, which is 772. P is the probability of success, which is 0.848. You just multiply them and put it there. It says, what's the standard deviation? The standard deviation of every binomial distribution is the square root of n times p times q. So you need to multiply 772 by 0.48 and multiply it by 0.52 and then take the square root of all to find the answer. for these two parts. So make sure for these two parts use formulas, because I don't think that we have any online calculators for that. Okay? Bye.